Question one, we have to complete a statement, which is the rotational symmetry of this shape. Of course, rotational symmetry means if you have a point, and in this case, the point is right in the middle, and it rotates around that point, how many times does it look exactly the same? Well, when it goes 180 degrees, it will be the same, and when it actually comes back, it will look exactly the same. So that's two places, so it has a rotational symmetry of 2. On the diagram, we need to draw lines of symmetry. Lines of symmetry are when they act like a mirror. When you draw a line and one side is a reflection of the other side, that's a line of symmetry. And so if we draw a line which is vertical through that center point, we'll say, well, one side is a mirror of the other side. But there is another one. And if we draw a horizontal line through the point, I don't think it has to be a dashed line. Just a straight line probably will do. And we would get the 2 marks for that. On the grid, draw a kite. Well, a kite is a specific shape in maths where you have, well, I don't know what shape it is. It's like this. It looks like a kite, right? And that's it. That's all we had to do. Any symmetrical shape will do. If you cut it in half, one side is a mirror of the other, either horizontal, vertically, but the top is not a mirror image of the bottom. That's what makes the kite. Write down 2 geometrical properties of a rhombus. Well, a rhombus is just a square that looks like it's been pushed over a little bit, so it doesn't have 90-degree angles anymore. What we do know, therefore, is all the sides are the same length. And just by thinking about the shape, we could say opposite angles are equal. Some of the less known properties are the diagonals bisect each other at 90 degrees, and adjacent angles will add up to 180 degrees because contour angles and parallel lines. So we'll just go with the opposite angles are equal. Calculate the value of the square root of 7.29, I think. Given that it's only 1 mark, you can just put it in your calculator and see what your calculator says. If you do put in your calculator, you'll get 2.7, and thank you for the mark. Write down a multiple of 9 between 100 and 110. Well, hopefully you would remember that 99 is a multiple of 9, so let's just add one more 9. 99 plus 9 is 108, and so we can just write 108 and we're done. How else could you do it? Grab a calculator and start punching numbers in if you were really stuck. Question 5a. Tanvi rounds the number 4896. She writes down 4900. Rahul says Tanvi rounded 4896 correct to the nearest 100. Explain why Rahul cannot be certain that Tanvi rounded 4896 correct to the nearest 100. And I think the reason we can't be certain is if you round it to some other value, you might get the same number. And look at it and you go, oh, if you round it to the nearest 10, that would turn into the 96 turns into 100, and then the 100 turns the 4896 into 4900. Look at the marks, it's only 1 mark. So if you found it confusing, don't waste your time on the question and move on. So we'll just write down if you round 4896 to the nearest 10, you also get 4900. So implying that, well, you can't be certain you rounded to the nearest 100 because it could have been rounded to the nearest 10. Calculate a value, give your answer correct to 3 decimal places. All right, we can put that into our calculator, I think. Right, so let's just throw it in the calculator. And we get 8.677966,102, and the number keeps going on, obviously. The calculator doesn't show any more decimal places. We need to round it to 3 decimal places, so we look for the third one. It's going to be 8.677967, but we don't write 7 because the 9 rounds the 7 up to an 8. And we should be finished. So you look at the marks and you go 2 marks, maybe there's marks for some working out, but it may be just for rounding to decimal places. I don't think you need to show any working out for that though. The heights of 4 sisters, and we've got 4 numbers. Work out the range of these heights. Give your answer in centimeters. Oh, centimeters. Notice they're all in meters. Well, the range is the largest number minus the smallest number is how we work out the range. So 1.65 minus 1.53. That's going to give us the range, which is 0.12. And we don't want it in meters, that's meters. We need to convert that to centimeters. And so 0.12 meters is 12 centimeters. The 4 sisters have a brother. The range of the 5 heights is 18. Work out 2 possible heights of the brother. Well, notice that the range is 12 centimeters. Now the range is 18 centimeters, which means either the brother is going to be taller than all the sisters to extend the range, or the brother is going to be shorter than all the sisters to extend the range. So if we take the smallest height, 1.53, and we add, it's in meters, right? We add 18 centimeters, we will get the brother's height, 0.18. And if we take the largest value, which is 1.65, and we subtract the 18 centimeters, we would get a possible height for the brother of the smaller amount. All right, so the larger one is 1.71 and the smaller one is 1.47. Either it's a big brother or it's a little brother. 1.71. All right, work out 2 times, and we have in brackets a -3, and underneath that we have a 7. Hopefully you remember that those brackets represent a vector, and when you multiply a vector by a scalar, the 2 is the scalar just multiplies every element of the vector. So you have 2 times -6 is 2 times -3 is -6, and 2 times 7 is 14. And we're finished. All right, the second one, we've got 2 vectors again, and we're adding. You add the corresponding elements. The top one is the x, and the bottom one is the y. So we have 8 minus 5 is 3, and we have -6 plus 2 is -4. Sahil and Anika share $78 in the ratio 5:8. Calculate the amount each receives. All right, if Sahil gets 5 shares and Anika gets 8 shares, there's a total of 5 plus 8 is 13 shares. And so he'll receive 5 out of 13 times the total amount, 78. And Anika received 8 out of 13 of 78. And they're the 2 answers. Put it into a calculator and you'll get 30 for Sahil and 48, of course, for Anika. You can check, do they add up to 78? Yes, they do. The diagram shows a prism. The cross-section of the prism is the equilateral triangle, which of course that means that this side would have to be 4 and this side also has to be 4 to make it an equilateral triangle. Draw a net of the prism on the 1 centimeter square grid below. So that just means every box has a size of 1 centimeter by 1 centimeter. And notice the dimensions on the prism. Okay, so what does it look like? Well, the bottom of that prism is a rectangle, which is 4 by 3, right? So we'll do it over here because I can't show everything on the screen. 3 by 4, and then connected to that bottom, there's another rectangle here, which is also 3 by 4. Notice it's connected on the side, which is 3. So we should put it over here. Well, let's leave the 3 there. 3 by 4, and there's another one which is 3 by 4, which is again connected on the side, which is 3. 3, 4, 4. All right, so we have those 3 sides, and then hanging off this of those rectangles, we have equilateral triangle of 4. You can put it anywhere. You could put it at the end, because notice that's 4, 4, 4. I don't know, maybe it looks nicer in the middle. So you have 4, 4, and 4, 4, where these sides are 4 each. All right, somehow we have to get that shape onto the squares below. And given the space that we have going horizontally, we may have to rotate that 90 degrees to fit it on our diagram. Okay, so it's going to fit horizontally, as I didn't think it would. But the tricky part about this is getting the triangle. It's an equilateral triangle, and so how do we work out the other 2 sides? Of course, they all have to be the same length. which is of length 4. So we would get a compass in this case, and we would put the point of the compass at one corner here, make it go to the width of 4, and then we would draw an arc, and that arc would cross over somewhere. And then we would do the same thing on the other side, where we take the point and we would put the point of the compass there and draw an arc from the other way, and they're going to cross over. Where they cross over, that's the corner of the triangle. So we can create the equilateral triangle. I would leave the lines there for the arcs in pencil, and hopefully we draw the straight lines with a pen. I'm just going to, for the sake of clarity here, I'm just going to remove them on this diagram. We'll do the same thing on the other side to get the other triangle. And that gives us the solution. The number of passengers on a bus is recorded each day for 14 days. Complete the stem and leaf diagram. Okay, because the stem and leaf diagram is in ascending order, it really helps if the numbers, it helps you avoid making mistakes if the numbers are in ascending order as well. So I would do that really quickly. I'd say, what's the smallest number? You scan it and go 15. And so, all right, so 15 is the first one. And the next smallest, 17. So let's cross out 17 and do 17. And then 18, and I'll just keep doing this. And so until I get them in ascending order. We've got 19, 19, so 19. We'll go across the top first. Then we look and see 22, 24, 24. So 22, 24, 24, 22, 24, 24, 25, 29, 25, 29. I cross them out so I can see if I make a mistake, and I write them next to the numbers again. So if I make a mistake, it becomes very obvious when I don't have enough numbers or I have too many numbers. 36 and 38. All right. Once they're in ascending order, a lot of things become easier with statistics, like finding the median, the range. Well, range is pretty easy anyway. But stem and leaf now. We know from the key down the bottom here, it tells us 1 and 5 represents 15, which is good. That's what we're going to start with, 1 and 5. And then 17 is a 1 and a 7, 18 is 1 and 8. These numbers should be as equally spaced as you can make them. And so there we go. All of the 10s are now in. We look at the 20s and we got 22. So that's going to be 2 and 2. 24, we'll have a 4. And these numbers should definitely line up with the ones above them. There's a 25 and a 29. And then there's the 30s, 31, 35, 36, and 38. And we're finished. The mean of 9 numbers is 17. Okay, so how do you find the mean? You add all the numbers together and you get the sum of all the numbers. You divide by how many there are, you divide by 9, and you end up with 17. Right, 7 of these numbers add to 132. Right, so we're interested in adding all the numbers together, and the other 2 numbers have a difference of 5. What are the 2 numbers with a difference of 5? All right, so if you remember how we worked out the mean, we added all of the numbers and divided by 9, and we got 17. So if we take 9 and multiply it by 17, we'll end up with the sum of all the numbers. 9 times 17 is 153. So all of the data values add up to 153, but 7 of them add up to 132. So the last 2 numbers must add up to what is left over. So 153 minus 132, which is that, is equal to 21. All right, so the remaining 2 numbers add to 21 and they have a difference of 5. You could just, I guess, just guess numbers and try to find out what 2 numbers add up to 21 and have a difference of 5. Or you could do this. You could take 21 and say, let's subtract the 5, and we'll get 21 minus 5 is 16. Divide 16 by 2, and we get 8. All right, so one of the numbers is 8, and let's add the 5 back on, and we'll get 13. 8 and 13 add to 21, and they are our last 2 numbers. Factorize completely. 9t squared w minus 3t. So we have to find, there's two terms. We have to find the highest common factors of both terms. Well, there's a 3 and a t in both of those terms. So if we take the 3 out of the 9, we're going to be left with 3, because 3 times 3 is 9. We take a t out, we'll be left with, from t squared, we're just left with t, because t times t is t squared. The w, of course, is remaining. And when we take 3t from 3t, we're left with a 1, and we have factorized completely. Sanvi makes some biscuits. She sells 5/13 of the biscuits, and she now has 96 biscuits left. Work out the total number of biscuits Sanvi makes. All right, if she sells 5/13 of the biscuits, what proportion or what fraction does she have left? She sells 5/13, she must have 8/13 left, which means 8/13 of what? Of the original amount. So that's the number of biscuits, right, that she made. Let's just call it B, is equal to what she has left, which is 96. So if we can come up with an equation like that, we can just solve it and go the number of biscuits, B, is equal to 96. We're going to multiply by 13, divide by 8, which of course gives us 156. Use your calculator, make your life easy. The first four terms of a sequence, 29, 22, 15, 8. Write down the next two terms. Well, we have to work out what's happening here. And the easiest thing to check is, well, let's just subtract numbers, right? So if we take 29, what do we subtract to get to 22? Well, we need to minus 7, right? And what do we do to get from 22 to 15? Oh, we do the same thing. We subtract 7 again. And 15 to 8, we subtract 7. All right, so we see a pattern there, and we can just go, we'll just keep subtracting 7. 8 minus 7 is 1, and 1 minus 7 is negative 6, and we're finished. Find the nth term. Okay, so they want us to do a term n is equal to something. And of course, we use n to represent the number. So if we go back to up here, we would say, and this is the first term, this is the second term, third term, and fourth term. Can we find out something that relates the value of n to those numbers? All right, what we do know is every time we're subtracting 7, and so we are going to end up subtracting 7 times n. Of course, then n is 1, 2, 3, 4, multiply it by 7, and you'll get the amount that you subtract each time. But for the first one, when n is 1, what do we 7 times 1 is 1. What are we subtracting 7 from to get 29? Well, we subtract 7 from 36. And so we'll have 36 minus 7n. Well, that's what we're looking for. That's the nth term. And we should just write that, I guess, in the answer space. Find the lowest common multiple. LCM is lowest common multiple of 18 and 21. All right, so we're looking for a number that 18 divides into, as well as 21 also divides into that same number. There is a process that we can use to solve this. I guess if you didn't know, you could get a calculator and just go, well, what are the multiples of 18? 18, 36, and just keep going and write out the numbers. Then find out the first one that 21 divides into. You could do that. But the process that we did learn was, let's find the prime factors. So 18, 2 times 9, and 9 is 3 times 3. So we know 2, 3, and 3. Actually, let's write multiplication signs there. 2 times 3 is 18. And if we do the same thing for 21, 21 turns into 3 times 7. And they're prime already, right? So if we want to find the lowest common multiple, we go, well, what's common to both? Well, the common is the 3. And so we're going to just use that once and say the lowest common multiple is going to equal 3 that is used once. And then we have to include all the other things that are there. So 2 times 3 times 7. And that's it. Put those in a calculator and we'll get 126. Write a large number in standard form. So hopefully you remember standard form, we take the first non-zero, which is 5, we then make a decimal point, and we have the remaining digits. It's going to multiply by 10 to some power. The only thing we have to work out is what is the power, and to do that we ask the question, well, how far did the decimal point move? And we can go to the number and just work it out like this. It moved 1, 2, 3, 4, 5, 6, 7, 8. It moved 8 places to get to right after the 5, and so it's multiplied by 10 to the 8 because it is a large number. And we're done. Part B, we have a bunch of numbers there. It says calculate the product of the largest number and the smallest number from the list. Give your answer in standard form. Okay, so we need the largest number and we also need the smallest number. The largest number is going to have the larger powers. So we have two numbers here which have 10 to the 10 squared. 10 squared is, of course, is 100. Which one is larger? Well, 6.2 is larger than 6.18. So that's our largest number. Let's just leave it underlined. What's the smallest number? Well, we're going to have the smallest power. We're multiplying by 10 to the negative 2. And so it's going to be either this one or this one because they're multiplied by the negative 2. Well, which one is smaller, 6.5 or 6.35? Well, 6.35 is smaller. So our smallest number is going to be over here, which is 6.35 by 10 to the negative 2. All right, so to give our answer in standard form, oh, that's going to be interesting. We have 6.2 by 10 squared, and we're going to multiply it by 6.35 by 10 to the minus 2. All right, the 10 squared and the 10 to the minus 2, they actually cancel each other out. All right, and you may ask, well, how in the world did that just happen? And the answer would be, well, when you multiply powers with the same base, you add them, right? And so we'll have 2 plus negative 2, and 2 plus negative 2 is 0. Sorry, it's 10 to the 0, and anything to the 0 is 1. So we're just multiplying by 1, so that's why I said they canceled each other out, because we now have times 1. So what we have left is 6.2 times 6.35. which we can put into a calculator and work out that 6.2 times 6.35 is 39.37. That is the answer, but it didn't ask us to present it like that. It said give it in standard form, and so we would change that to 3.937 by 10 to the 1, which is just by 10. I don't think we need to write the 1, but we will write it just to be safe. Okay, these two triangles are mathematically similar, which means there's a scale factor which you can multiply the lengths of one and you'll get the lengths of the other. Find the value of x. Okay, so the scale factor is, we want to definitely go that way because we multiply 1.61 by something to get x. And that would be multiplied by our scale factor. All right, this is one way you can solve it. And so you go, well, what's the scale factor? 2.8 times the scale factor is 3.2, which means the scale factor is equal to 3.2 divided by 2.8. Well, how do we find out what x is? We multiply 1.61 by the scale factor, which means x is 1.61 times 3.2 divided by 2.8. You can, if you're more comfortable working them out as you go, you can do that. Put it in a, and we get 1.84. Okay, is there another way? Well, yes. It's like we're using scale factor without even using the scale factor. And so the other way is, well, the ratio of the sides. The ratio of the sides is the scale factor. So you could do this. You could say, well, which sides are equivalent? The 3.2 over the 2.8, they're the equivalent sides, is equal to the x over the 1.61, because they're, well, equivalent corresponding sides as well. So we could do that as going, these are the ratio of the sides, but what you'll notice, or you may not notice, is we just worked out the scale factor without actually saying that. If you rearrange that equation, of course, you'll end up with the one down here and you get the same answer. Okay, simplify. So we're using index laws here. When you're dividing, you subtract the powers. Okay, so this would become x to the 12 minus 3, and 12 minus 3 is 9. You got correct. When we have brackets in a power raised to a power, we multiply them, and so it would become y is 2 times 5. What's outside the brackets get distributed to everything inside the brackets. But if there is a power, you multiply, so that becomes y to the 10. And the trickiest one, I guess, is find the value of p. The way that we learned to do this was if we can make the other side look similar to the power side, in other words, we need the same base, we would have a good chance of finding out what p is. And so what we want to do is say, well, can 81 be represented as 3 to a power? And hopefully you would think, oh yeah, 3 times 3, 3 squared is 9. And 9 nines are 81, and so 3 to the 4 is 81, or y4. 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So that's 4 of them. And then we'll go, well, it kind of looks the same now, but not. But can we take that 3 to the power 4 and move it to the numerator? And yeah, there's the index law that allows us to do that, and that's when we make it negative. We make the power negative, it can move from the numerator to the denominator, denominator to the numerator. And once we get to this point, it's kind of obvious that p is negative 4. We're multiplying two mixed numbers, and we're not allowed to use a calculator, so we have to show steps to make our, well, to get the marks, I guess. So how do you multiply fractions or mixed numbers? Well, when fractions, you multiply the numerators together, you multiply the denominators together. So we need to turn those into improper fractions. To do the first one, we multiply the 4 by the 2 and we get 8. We add 1 and it turns into 9. So the first number is 9 on 4. And we're going to multiply that by 3 times 3 is 9, plus 2 is 11 on 3. And they're the two numbers that we're multiplying together. All right, so you could do that and you multiply them and you would get 99 on 12, or we can make our job a little easier by canceling what we can. We can divide the bottom of this one by 3 and get 1. We can divide the 9 by 3 and get 3. And so then that will turn into 3 times 11 is 33, and 4 times 1 is 4. All right, that's the answer, but we need to show it as a mixed number. So how many times does 4 go into 32? Well, 4 eighths are 32, and how many is left over? Well, there's one more to make 33. So 8 1/4 is the answer that we're looking for. Solve the simultaneous equations. Well, there's two ways to solve simultaneous equations. One is by elimination and the other is substitution. For substitution, you make it so that a variable equals something. So you would like to say x is, what would you say, 14 minus 6y divided by 5. That's messy, and then you substitute that into the other equation. So substitution is a very difficult way to solve this. A better way would be elimination, and to do that, we want to make the coefficients, the numbers out of front of a variable, the same. So we could make 5 and 2 the same, or we could make 6 and 8 the same. I think 5 and 2 is easier to make the same. And so what do? We are going to take the first equation and we're going to multiply it by 2. Why? Well, because 2 times 5 is 10. And we can also turn 2 into 10 as well on the other equation. So when we multiply by 2, what we're doing to an equation, what we do to one side, we do to the other side. And so we're going to multiply both sides by 2. The 2 on this side gets distributed, so it's going to be 2 times 5 and 2 times 6. And so what ends up happening is we just multiply every term by 2. So the first equation would become 2 times 5 is 10x, and 2 times 12, 6 is 12y, and 2 times 14 is 28. And that's the first equation. Everything, both sides have been multiplied by 2. For the second equation, we're going to multiply both sides by 5. So because 5 times 2 makes 10, and so we will have 10x, which is what we want. 5 times 8 is 40, so we will have 40y. And 5 times 7 is 35. All right, the reason we did that is we can take one equation and subtract the other equation. What it means is you get 10x minus 10x, and 10x minus 10x is 0x. which means there's no more x anymore. That's very helpful. That's called elimination. Right, but which one do we want to subtract? Do we want to take the top one, subtract the bottom one, or do we want to take the bottom one and subtract the top one? And I always look at them and say, well, which one is got the higher coefficients? I'm going to subtract the other one from that. 40 minus 12 turns into a nicer number than 12 minus 40. So let's take the second equation, and if we call the equation 1 and equation 2, we can tell everyone exactly what's happening. Let's take the second equation and subtract the first equation, and what do we end up with? Well, we've got 10x minus 10x is 0x. We have 40y minus 12y is equal to 28y, and we have 35 minus 28 is 7. Okay, so y is 7 divided by 28. 7 divided by 28 turns into just 1/4, and we have found out what y equals. The next thing we have to find out is what x equals. So choose any existing equation, and we're now going to substitute y in. I'm going to take y, I'm going to put it into, well, it's not labeled, the 2x plus 8y. And so what we would get, we'd have is 2x plus 8 times y. We know that y is 1/4, and that is equal to 7. Okay, 1/4 of 8 is 2, so we have 2x plus 2 is 7. So 2x is 7 minus 2, which is 5, and that of course means that x is 5 divided by 2. Well, let's just write 5 on 2. All right, so for our answers, x is, did it say we have to have an answer in a particular form? No. Okay, so let's leave them as fractions. 5 on 2 and for x and 1/4 for y. And I think that's good. Right, well, we have a composite shape before us, a triangle, and we're told 1/4 of a circle. They tell us the right angle triangle, the radius of the circle is 5, OC is 6. That's on the diagram. Calculate the area of the shape. Well, because it's 1/4 of a circle, we would recognize that's the center of the circle, and this length would also have to be 5 because it is the radius. So to find the area of the shape, we're finding the area of two things and adding them together. We will find the area of the 1/4 of a circle, which is that, and then we're going to add the other shape, which is the area of a triangle. And that is it. That's our answer. So let's break it up then. The area of the circle, let's just say AC, it's 1/4 of a circle, so it's going to be 1/4 of the area of a whole circle. A whole circle is pi r squared, hopefully you remember. And so this turns into 1/4 of pi times 5 squared, because 5 is the radius. For the triangle, the area of the triangle, it's a right angle triangle, which means we do have a base and a height. It's just a half of base times height, which is a half of, it doesn't matter whether you have the 6 or the 5 as the base and the height, because that triangle can be rotated, of course. So a half of 6 times 5. We add those two areas together, and we have the answer for the area of the shape. And that is it. Calculator time. Okay, so we can just put it all in the calculator and get our total area is equal to 1/4 times pi times 5 squared is 25. And we're going to add the area of the triangle, a half of 6. Half of 6 is 3. 3 5s are 15, so let's just add 15. And less to type into a calculator. Turns out to be 34.63495. Right, it goes on. What does the front of the paper say? Give your answer correct to 3 significant figures. So we should say 34.63. So it's just going to be 6. And that is the area. Units, centimeters, and squared, because it's area. And we're finished.